Good afternoon. My name is Angie Sandritter, the CEO of RippleWorks, and I have the pleasure of introducing to you Dr. Mark Derriso. We've had the pleasure of being able to work with Dr. Derriso, and I know that you're going to find this session to be very informative and also enjoyable. So I'm excited and honored to be able to introduce him. Dr. Derriso is currently serving as the Chief Engineer and Chief Data Officer at the 711 Human Performance Wing with the Air Force Research Laboratory, Wright-Patterson Air Force Base in Ohio, so that's the location. He is responsible for providing technical oversight of human performance technology development to ensure successful product transition to customers and end users. Dr. Derriso is spearheading the organization's digital engineering development for implementing a data analytics and management ecosystem for human performance research and operations. He is an accomplished researcher with 80+ technical publications in the area of materials, structural characterization, human monitoring systems, automatic controls, artificial intelligence, autonomous systems, and human performance. He is particularly experienced in creating innovative solutions using multidisciplinary, interdisciplinary approaches requiring the integration of machines and human systems using advanced systems engineering principles and methodologies. So with that, I'd like to introduce Dr. Derriso. Thank you.
So good afternoon, everyone. Angie, appreciate that introduction. I didn't think you was going to read it all, but I appreciate it. That was kind of lengthy. But I appreciate the invitation to present here today. I'm excited about this opportunity to talk to you about some of the things we're doing in the area of artificial intelligence, digital engineering, and also human performance. And hopefully, if I do my job correctly, you'll see how they all integrate together to come up with a total solution or product at the end. So here's an outline of my talk. First, I'm going to talk a little bit about artificial intelligence. Obviously, you know a little bit about it, but I'm going to tell you the definition that we're working off of and how we're building our products. Talk to you a little bit about a methodology we're using called Quest to try to generate some new ideas in AI. And then I'll go through a use case with, ironically, case of an intelligent architecture that or AI architecture that we built, and show you some of the capabilities of that. Then I'll go and talk about digital engineering. Anybody heard that term before, digital engineering? Yeah, so this big on DoD. DoD is pushing this. I think industry is as well. Talk a little bit about the strategy and AFRL vision and where I work. And then I go into a human performance, which is going to serve as my use case. Talk about a theory of performance that we come up with and how you do lifecycle management. So that's my talk, and let's get started. So let's talk a little bit about AI, right? So when you hear the term AI, first thing you got to understand is what is intelligence, right? Intelligence is the ability of an agent. The agent can be a human agent or a computer agent to create knowledge from experience, thinking, sensing, and culture. So it's being embedded in an environment and you learning from that environment that you are in to accomplish a task. Now here's a caveat. Just because you have the intelligence don't mean that you can perform that task well. It means you have the information that you need to perform that task. I'll get to performance later on, but it's more like skill acquisition, right? How you're able to acquire that intelligence or that skill. So artificial intelligence obviously is a machine being able to possess that intelligence to perform a task. So some of the sub areas of AI, people always, conflate sometimes AI with ML. ML is a subset or a subdiscipline of AI using statistical models or deep learning, which we are seeing today, from data sets that's been trained and examples that it's used. Then other sub areas of AI can be planning, vision, knowledge, representation, also looking at natural language processing. So what is knowledge? So hopefully I'll break it down to you to set the context for this presentation. Knowledge is used to create meaning from those observations, and I think that's key, right? So you can collect data, you can display data, you can show data, and anybody that work with me, I always say, ask the so what question. If you can't answer the so what question, I think we got more work to do once the data's been collected, right? So let's continue. So there's three ways. Anybody heard the three ways of AI? Anyone? No? Oh, I see some nays hollering, right? Nodding. So the first wave was in the 60s and 70s, right? It was more complex programming using very little data. Think of it as more of a decision tree, right? Or heuristics you built into to make the systems appear to be intelligent to do what you want. Generated a lot of good applications, done a lot of good things for it, handcrafted knowledge, and it's still bringing some value today. So that was the first wave. The second wave in which we're in right now, which is more or less the 80s to the present, is simple programs but a lot of handcrafted data. This is where your statistical pattern recognition and things come into play, where you're able to train algorithms on data you have collected from different sources in order to do or behave the way you want it to behave, right? And if you remember, I don't know if you guys remember or not, but it was a time where AI had overpromised some things and it kind of got lost out of favor. But then it came back, I think, pretty well with what we have today with deep learning and things like that. Most of my talk is going to be on this third wave, right? That is yet to be, the timeline is TBD. It's to use contextual adaptation. How can we have this system, do things like have common sense, right? You would think that if I'm an intelligent agent, common sense should be there, but a lot of times it is not. It uses the data it's trained on to behave a certain way, right? So if something wrong with that training set or that data that you use the training on is going to behave a certain way, and so if common sense was not put into that algorithm, then it won't have it. I'm sure everybody heard of explainable AI, that alignment, so you understand what the agent is doing, why it's doing what it's doing. And then one of the biggest things we talk about is the unexpected query. Those things or environmental situations that the AI encounters that it was not trained for. So if it was not trained on that, what would it do when it encountered these situations, right? So how do we make it more robust in that fashion? And then you can say imagination. We can talk about simulation. How can you use data to simulate things that might occur and do some prediction associated with that? So that's the third wave, and that's mostly what I'm going to talk about today, is trying to add some robustness, right? Some more, maybe have it less fragile in some of these domains or contexts from the military standpoint that we care about. So there was a Defense Science Board study that talks about some of the current states of AI and where it's at and some of the vulnerabilities. One of the things that came out, it talked about the AI systems suffer from a number of novelty, unsolved vulnerabilities, and one of them talked about poison data attack, right? Again, I just talked to you about AI and the way it's developed. If you somehow, let's say, add some different data to that training set and you train it that certain way, that's what we mean by the poison attack, especially from an adversary who can actually have AI poison your data from a training set standpoint of view. And then again, if it just does what it's trained to do, then sometimes it can respond in a way that you might not want it to do. Also, from examples, there's no way, that's very difficult for you to be able to train an algorithm on every scenario that's going to encounter. That's a very difficult thing to do. It works well if you have a bounded data set and it represents the total population of the data that you're going to experience and see during operation. It works fine. It's awesome. It's those things that when it encounter those things that you have not trained it for, how to respond to that. So that's one of the things that came out of there as well. So, and this is different from the traditional vulnerabilities that we've seen in the past where we talk about buffer overflows. But what it does point out is that how powerful AI is right now and how it can do things, especially computational processing, much better than humans can do, right? Because we take in data, at 30 to 50 bits per second? We take in that data at that rate. AI can take in, the computation power can take in much more data than that. But it still has some vulnerability in doing some of the things, I would say, based on like common sense, said, nah, that don't make sense. I'm not going to do that you and I have that maybe this AI might not have. Am I making sense to everybody? A lot of head nods. That's great. Okay, let's continue. So this is one of my favorite charts. Jeff Jonas, IBM fellow, right? Have everybody seen this chart before? Okay, I'll explain it. So on the left, on your vertical axis, you talk about the process and the conductivity you have right now with all the processing power that you have. So you have a lot of ability to collect data from sensors and other things, right? Over time, it's growing. But what's missing is the sense-making algorithm. That has been flattened out for the most of the part, right? We see these amazing things that AI is doing right now, and I'm impressed with it, but it all depends on how much data that you train for it to do it. So he came up with this thing called enterprise amnesia, where we get a lot of available data, a lot more knowledge coming in, but we're not exploiting it at the same rate because these algorithms don't exist. Okay, so that's one of the things that we're trying to attack with some of the technology that we're doing. So I had to bring up my advisor, my mentor, Dr. Stephen Rogers, go by Cap, right? Everybody knows Stephen Rogers, Captain America, so that's the connection there. But he came up with this approach he called qualia, or quest. It's based on qualia. Anybody heard qualia before, that term? Right, so qualia is this term that a lot of people are not familiar with, but we use it all the time, right? It's our subjective experiences that we see on a daily basis. Everybody in this room can be looking at the same thing in the same environment and have different experiences, right? So we use those experiences and we use our own way we internally process this information to function in the world. Although we're taking in data the same, we might have different feelings, but we also respond appropriately for the situation. So what we want to use qualia for, if I use that term, like philosophy use, like I said, for subjective contextual information, but we want to see if you had this in the AI system, is there a benefit? Will allow you to help you generalize and exploit data much better than what we see today. Okay, one of the things we're trying to do with come up with a qualia, I should say, fundamental laws, very similar to physics, and we came up with some tenets associated with this, right? So it's really about how we use qualia to create internal representation to help us make decisions or respond based on stimulus that we see in the environment. I'm not going to read it all, but I'll go over some of them. Structural coherency. It talks about having a stable, consistent, and useful representation to be able to respond appropriately. It's almost like how a person feels to help you make decisions. Situation-based processing versus just variables, so how we use situations as variables to help us make decisions. So it serves as almost like a cognition function. What are the different narratives that might come out of the data set that I'm seeing? How we use simulation to think about or imagine about what are the different plausible narratives that might take place. And then qualia, I already talked about this, the bottleneck, and have almost like a reduced order model internally so you can model the world in a reduced fashion because, again, the limitations of humans is 30 to 50 bits per second, but how can you have a model that allows you to respond and function in the world appropriately under different situations? We all do it, right? So it's definitely possible. So those are the things, approach that is based upon some of the research that we're doing in this space. So I'll continue. So machine conscious architecture or artificial consciousness. Anybody heard of this field before? It's a field under AI. No one heard of this? All right, so let me continue. So it refers to the understanding of how to examine consciousness and what it can help us out with informational machines and processing. So that's kind of what we after is, how could we get these machines, not just based on data it's trained on, that's part of it, but also reason and make better decisions if it encounter things that are not appropriate to respond to, or have an understanding why I should not respond a certain way for this information. Global workspace theory is one of the oldest and probably most popular conscious architectures that exists. I'll tell you a little bit of what it includes. It includes conscious and unconscious processes, right? Everybody familiar with that? Conscious and unconscious processes, Sys 1 and Sys 2, think fast, think slow, right? So that's kind of what is based off of that, right? Then you have the conscious process that compete to enter the global workspace. What that is the center. I have a pointer, but it's the center there, the global workspace. That just means that you cannot attend to everything at the same time, so it had to be a party there. So it competes for that. Then the global space represent worker memory. So inside of that circle there, it's represent worker memory. And then the spotlight represents the focus of attention. So if you look around at the circles around the bigger circle, you have your perceptual system, attention system, motor system, evaluative system, long-term memory, all competes again in the work and memory, which is global workspace. And then based on your goals or what you're trying to achieve, that's what enter into for additional information to help you respond a certain way for that situation. So hopefully I'm gonna make it more sense as I go along. So this is an architecture that we developed based on the global workspace theory, and it's called CASE, Conscious Architecture for State Exploitation, and is based off, like I said, GWT. And the goal is to generate these artificial consciousness to enable goal-based decision-making and adaptation, right? So when you see something that's not right, or if you see something that's not right, how you make that adaptation to go forward with. There's a lot on this diagram. I'm gonna step through pieces of it, but the four main pieces I'm gonna step through is the environmental operation processing that serves as contextual information to help feed the algorithm. Then state characterization is how you characterize the state based on data that's coming from the environment. And then the other one is state selection. And so that's a key one because that's where it says, does this make sense based on the information that I received from my algorithm? So it still uses data, it still uses some training data, which serves as your unconscious process, but it has a conscious process that says, does this make sense, and should I continue or not? And then you have your action selection based on the goals, right? Then you have your worker memory in that square there, and that serves as your spotlight in the global workspace theory that I showed you on the previous slide. I would ask if any questions, but I don't want to hold up the presentation. All right, so I'm gonna break down each of these very quickly. I'm not gonna spend a lot of time on it, but when I talked about the environment operational data processing, this is data that's out in the environment trying to get some physical measurements from whatever you're trying to characterize or whatever you need to know something about. So you have sensors or data coming in from that. It could be things like, these are just examples. It can be like temperature, pressure, and et cetera, right? These physics-based information. But you also have other things like speed, loads, and things like that. This was an example that I was using actually on a fighter aircraft, the F-22. It was used to actually pick up damage state on a aircraft structure, right? So we use these sensors to collect data to pick up a damage. How many know that a crack sensor doesn't exist? There is no way to directly measure a crack. So everything we do is sensors using different techniques to get data, train the algorithm, use pattern recognitions to understand that there's a crack there based on the response of that system. What's the problem with that? There's a problem because different things could change the response of that sensor data. So you gotta eliminate those things that's not directly correlated to a crack to make sure you say, hey, there's damage there, you need to do some maintenance or something associated with that. But this was built off that. That's why you see things like temperature, pressure, speed, and so forth. Okay, I just wanted to get a little bit of that background And then there's the state characterization module, and this is how you characterize that state based on that data that is coming in from those sensors. You can see where it said damage algorithm 1, 2, 3. Those are different algorithms that was trained using statistical pattern recognitions in different ways to look at it from a different point of view. So it's not one algorithm. There's multiple algorithms saying and confirming whether it sees damage as well. It's almost like you've been in an accident, a car accident, and you have different points of views as witnesses to confirm what one or the other is seeing. So some of these was based off statistical pattern recognition, some of these based off neural networks, and that's how we trained that to actually go into what a state estimation is. So hopefully that makes sense, and then those what we call plausible states, or plausible narratives of what could be taking place in this algorithm. Then we have your selection, and the selection is also based on what happened in the past, previously. It's based on some physics-based models, and those state estimations that I showed you earlier, talked to you on the previous slide. And that's how the state was selected. I'll give you an example. So I told you about F-22 aircraft. I told you about cracks in F-22 aircraft. Structural cracks are generated due to loads. If the aircrafts are flying and they have loads on it, it could grow that crack depending on how it's been loaded, right? If the aircraft have not flown and no loads was put on it, would the crack grow? It shouldn't. But in some of the cases, our algorithms will say it grew X amount longer from what it was previously. So we know something wrong there, right? If it have not flown, no loads, but it was some in that data set that it collected, or something happened in the environment that we did not capture in our representation, that will say the crack has grew. So it looks similar to something else. The problem with trying to monitor and do estimations on some of the things we're doing on it is that they're ill-posed problems. If you don't know what that means that there are multiple solutions to that one data representation. And what we're trying to do is narrow down and figure out which one is true, right? So that's what this is all built upon, okay? And then state selection is based on what I'm trying to do. What is based on what I'm trying to do, and what the data set says, and which one agreed and not agreed. I didn't go into that algorithm, but there's an algorithm there that helps you determine which state to choose. But based upon that, it chooses a state, it has a goal, and it says, can I actually complete this mission? So what I actually start doing, besides saying, hey, did I get that damaged state actually correctly? I'm more focusing on how does it change my decision. There's a difference there, right? If I get the crack length off by 10%, it might not change my decision I need to make for a mission, right? So you gotta look at the sensitivity there. But the bottom line is this state selection looks at the goals of what you're trying to accomplish based on what the current state estimation is, and then make a decision to a commander and say, here's what we recommend you doing, and here's the risk associated with it. So hopefully that gives you a little bit idea behind how this algorithm, this case architecture work versus some of the other AI methods that's strictly based off training, hopefully. Right? So let's talk a little bit about digital engineering that I mentioned earlier. So digital engineering is something that the Air Force, or I shouldn't even say Air Force, DOD want to go to really how you operate more in the digital way, right? How can we actually digitize most of the processes that we have and we operate across the organization right now in a more digital fashion? So the bottom line is, the vision is modernize how the department designs, develop, delivers, operate, and sustain the system over the life cycle of that entity. So how we go from research to maturation, to transition to the customer, to operating in the field, more in a digital way, a more seamless way, using data really as the underlying thread amongst them. And you can see how it's defined. I won't read all that, but it's an integrated digital approach that uses authority sources of system data and models as a continuum. Like I said before, they want to use a lot of modeling and sim, a lot of data analytics to to create a digital data trail associated with it, so they'll know how it was developed, the origin of it, how it was developed, how it performed in tests, and even a way to predict how it will perform in the future. So that's kind of what they want to do with that. There are 5 goals associated with it. I'll read through these very quickly. One is to formalize the development, integration, and use of models. Again, use models to help you determine and develop the system, how it works, and make decisions along the way. Provide enduring authority source of truth. Like I say, everything now is going to be, they want to be data-driven, validated information to help you make decisions, just not subjective type opinions. They want to incorporate innovative and improve the digital engineering practice. Model-based system engineering comes to my mind when I think about that. Anybody heard of model-based system engineering? Yeah, there you go. Model-based system engineering is what I think about when I hear that. And then establish a supporting infrastructure and environment. That is that infrastructure that it can be a cloud environment, it can be an on-prem system, but it allows you to seamlessly work in a digital manner versus paper presentations and things along those lines. And then transfer the culture. That's a very difficult one to do, but how you transform the culture to work more in a digital fashion is another one of their goals. So this is just another a diagram that came out recently, a few months ago, the DoD put out, talking about its desires for digital engineering. And I won't read all this on this chart, but if you see that the big circle in the middle, right, and you have the other orbital circles, if you will, kind of look like a space thing, right? We're at the right place for that, right? So in the middle, it talks about, this digital engineering ecosystem and what's all associated with it from an infrastructure standpoint of view. There's hardware, software, networks, tools, workforce, and different approaches. What are the different processes we use? What are the methods we use? What are the practices we use? But you can see what they want to be able, this infrastructure to be able to do. Create a digital twin. Everybody familiar with digital twin, right? How you can have a model that represents a real world component, and you can actually do simulations with this model and understand the behavior, right? So that's what they want to be able to do with this. These are just examples. Digital thread is those data points I told you earlier about those data points associated with your requirements analysis or your architecture development or your cost estimation. They all want that digital as well. Then you could talk about the artifacts that come out of it, the specs, tech drawings, designs, and so forth like that. And then your models associated with whatever you're building, right? Requirements model, functional models, and you can see I highlight human performance models also. It made the chart, which I was happy to see, but that's also part of it. So it is DoD's goal to say we're going to work more in a digital way, we're going to do more data analytics, we're going to make decisions based on this data, and we're going to hopefully make this process more efficient and more effective in the future. That's the goal. And then my major command, which is AFMC, said we don't just want to limit it to life cycle models that you see up top or life cycle applications. We also want our functionals to do it. We want to use it for program management, contracting, logistics, and so forth. So our goal is to actually apply the same technology, because the technology and tools are the same, it's just applying it to a different application. So we're going to use that to do this as well. I work in AFRL, like I said before. This is the acquisition cycle, if you're not familiar with that. The acquisition cycle is how we develop and transition technologies. So in the far left, you talk about a TRL level 1 through 6, and that's more of the research side of things, so AFRL works. We want to use this too to make sure that we have the right handoff to our engineering and manufacturing process and hand them, models or some software tool or something to help them actually continue to mature this to the field. And we believe from an AFRL standpoint of view, it will help us with help us more effectively and efficiently do our system engineering principles to expedite the design process and deliver our products. So that's kind of the motivation from AFRL standpoint of view. And we actually have an AFRL chart that talks about what they want digital engineering to do for them. We call it MADE, model, analyze, decide, and execute, right? Our goals is how we get to faster research, right? How we do better decisions, how we streamline our transitions, and then how we decrease the friction associated with our business and operations. So that's kind of what we want to do with digital engineering overall. So hopefully you can see within everything I said, little parts of where AI can play and to help us do these things, because we're going to have a really software-intensive, analytics-intensive environment that I think AI can help us out through multiple nodes or help us move data or help us analyze data throughout that environment. So now I'm going to roll in human performance and hopefully roll this all together. We'll see. So human performance, right? So I'm going to talk about a little bit of my experience. Like I said, when I talk about intelligence, right, I talk about people being agents. So I'm going to talk about my experience in being an agent through different lenses, right? So here's my human performance experience that was not in my bio that Angie read purposely, right? Because most people don't hear about this side, but if you get to know me, I love to share this side with you, right? So I had the opportunity to participate in sports. A lot of my, earlier in my career, my life, from football to baseball to basketball, track, did all that. I also served as a personal trainer, also was a football coach, right? And I also serve as a human performance professional, which I'm here talking about today, as a principal investigator and also chief engineer. So why is this important, right? We just talked about, earlier when I talked about intelligence, I talked about knowledge and the so what question. So I'm gonna share with you what I learned during my experiences in these different positions, right? And that's what that's just saying. From different lenses, I'm gonna show you my experience, right? First, I'm gonna talk about human performance and the it factor, right? How many heard that term before? The it factor, right? Why we call it the it factor? I have my opinion, but why do you think we call it the it factor? Anybody want to take a guess? You know when you see it. That's a good one. Anybody else? My opinion is that because we don't understand it, right? We call it because we don't understand it, right? And I had to learn that the hard way, and I'm going to share that with you, right? So we always talk about the it factor. It's associated with this age-old argument, nature versus nurture, right? Either born with it or not. I was coaching a kid one time, and I thought he had a lot of potential. And one of the experienced coaches came over and told me that I coached running backs, that's the position I played. He said he would never be a running back. I tried to teach him for X amount of years, and he said, running backs are born and not made. I said, okay. I listened to him. I mean, he was more experienced than me. I was just out there coaching for the first time. But I definitely proved him wrong, because that guy ended up being the star of our team. I just trained him differently, right? So I just trained him differently. But this is something that's been around for many years, where first responders, military, and athletes alike wanted to have a way to predict whether someone can be a good performer or not, whether someone can perform and have that it factor, right? Either have it when you see it or develop it, right? We're still doing that. We're still trying to figure that out. So my hope is that when we're done with this presentation, you agree with me that maybe there's some development that can take place where you can substantially improve your performance if done in a systematic way. So that's my hope at the end, right? So, what is human performance, right? That's part of the problem, that there's so many different definitions that exist today, and it's still going on. So the term is used quite frequently, but there's no standard definition. I've been working at the Human Performance Wing for 10 years, and I like to go around and ask people, well, what do you mean by performance? And a lot of folks don't have answers, right? So how do we know we arrived if we don't know what we're trying to get to, right? So that's a problem, right? So here's just a sample of definitions that I came up with. Performance is behavior plus results, right? Then we got human factors talking about working with machines, right? The efficiencies or the ability to work with equipment to perform a certain task or role. There's human performance capability and limitations in the aeronautic operations, right, which have an impact on safety and efficiency. So that's for aeronautics. And then the human competency by Dr. Gilbert talks about worthy performance, behavior, and consequences. Then I'm going to point you to this working definition that we're working with, right? And I'm going to read this one to you because I think it's important to hear it all, right? Or you can read it yourself, right? Human performance is a holistic weapon-based life cycle program designed to maintain, enhance, and augment specific physiological, cognitive, emotional, spiritual, and behavior changes through evidence-based practices to achieve peak performance and adaptation in diverse and extreme environments. Now raise your hand if you would have came up with that definition for human performance. Anybody? Right? No one would say that. But I think it's all important what they're saying in this definition. Right? So I think it's all important. When you work human performance, I was very appreciative to see this versus the others. Because this I can work with a little bit. I have no idea how to do those other ones, right? So let's continue, right? So as a player, right, I did the training they want me to do, which is the weightlifting, the bench, the squats, and all that other great stuff. I did the sprints they wanted me to do. And then I was evaluated on those same type of training exercise. That's how they evaluate you, right, on those things. But when you get called in the office, I don't know if you guys know this, but you get called in the office every spring. You say you have a 4-year scholarship, they say that, but if you don't perform, you don't really have a 4-year scholarship. They call you in the office and say, they look at the stats. You know, for my position, yards per carry or touchdowns or receiving yards and stuff like that. There's a mismatch, right? Because they say do these things, and they're assuming those things going to turn over to those performance measures in the field. So what I realized through my journey, I told you I was going to share this with you, the things that I need to perform in a game that was not taught to me. It was not in that weight room where I had to do extra stuff on my own and try to figure it out. So that's number one. So we talk about AI and training sets. If I would just put that training data in, I wouldn't have got that out. That make sense? Okay, hopefully it makes sense. Right? So I was racing as a trainer, right? So I did what I was told, right? I did as I was taught, I should say. I trained them the same way that I was taught. Bench squats, deadlift, clean, jerks, whatever the case may be. Had them run sprints, and I evaluated them on those same things, because I was. And the assumption we was making is that, again, those performance metrics will progress improvements in the field. And they did not in a lot of cases, right? But I just was mimicking what I saw because, again, yes, I was an agent, and I'm sitting there taking data in, but I didn't understand the meaning at that time, right? I was taking data, I didn't understand really what it meant until later on, so I was doing the same thing. And I always got to tell this story with this as a trainer. So when you train and when you play football, I'm sorry, all my story is going to be related to football because that's what I like, so I apologize for that. So, but when you play collegiate, and probably even in high school, they have these boards on the wall in the weight room, Anybody seen these boards I'm talking about? These is weightlifting boards, right? How much you can lift here, there, of these 3 main lifts or 4 main lifts, they have them out there. And you could be part of the 1,500-pound club or 2,000-pound club, whatever it is now, right? And they celebrate that, which is good. But my story is, again, through my observation as a player, I seen a guy who had all those accolades and did well in the weight room. He never played a game. He never played a game. So is that the right thing we should be measuring? That's a question, right? Is that the right thing we should be measuring? So as a coach, right? So I got to coach and got to see these players, develop and try to help develop them. So now it's time to execute, right? So before I talked about intelligence, the acquisition of knowledge, and I told you that don't mean that they can perform that knowledge well. It just means they have the knowledge that will enable them to at least try to perform, right? So as I tried to execute these plays in the field, one thing that I realized that just because you play don't make you a good coach. Anybody tried to coach who have played before? Anybody? It don't make you a good coach, right? I'm not saying you weren't, right? I'm saying I wasn't, right, when I first. And it's back to this gentleman up here said the it factor, right? It's what he said. He said, you see it. And as I was seeing these kids run these plays as a running back, I told them 100% that was not right. I said, that's not right. Why? Because I see it, right? But here's where I felt. I felt when he came up to me and say, Coach, what did I do wrong and how can I get better? I didn't have an answer for him. I knew it was wrong, right? And that bothered me, so I had to go and learn about why that was wrong. I had to go figure that out, right? But I knew it was wrong, right? So anybody who wanted to coach, do your homework first before you go out in the field, because you might not be ready to do that, right? So that's my warning. Then the most popular assessment drills I told you before, weightlifting exercise, was not reliable predictors for field performance at all. Was not, period. There's a huge chasm, in my opinion, between performance in the weight room and field performance. So what I'm saying is there's a big difference between how you train and does that transfer over to the field. That's called transfer learning, right? If you never heard that term, that's the term, transfer learning, right? And what I realized is that some other players did not have the innate ability to perform real-time decisions and the physical execution. There's something to acquire that knowledge. They could probably recite the playbook back to me, but they could not execute it on the field, right? So that was a big chasm that I saw. So, observers as a researcher, right? Varying definitions, still continuing today. I already talked about that. Most of performance evaluation does not reliably transfer it over. I already talked about that. I think field performance is not well understood. We could say he has the it factor, she has the it factor. We could say that, right? What makes Patrick Mahomes so good? Anybody know? You could say it, the it factor, right? Because we don't know, right? We don't know, right? So there are no standard or established predictors for operational performance. And then I already told you, the people are born with it or they're capable of being developed. So let's see if I can convince you. So training methodology. So I'm gonna talk about training methodology as we see today, right? Most of them is ruling strength and conditioning. Most of them, I just went over that with you. So the question I have, right, is you see on your left bottom picture, right, the push-ups from a military standpoint of view. Air Force got to do push-ups, sit-ups, and mile and a half runs, so forth like that, right? My question is, we do these things, but then they say, okay, go do that on the far right. How many think if I had you do some push-ups and then Or are you prepared if I put you on the field like that? Anybody? I got somebody we can sign you up for the Air Force today if you want, right? So those are the things. And then up top, right? I already picked on squats already. Does that mean you can do that? There are so many different factors that we're not accounting for when we train to try to get these type of performance. So that's why I think, I forgot this was coming up. So indoctrination program to special op for the Air Force, we have about a 90+% washout rate. Do you know what that means? That means they don't make it through the program. And I had an opportunity, I have no idea where I'm at on time. I had an opportunity to witness one of those training programs. And so I was there and I was excited about being there. And they had this older gentleman, I say older gentleman, but he was like 27, 28, for special ops, right? That's old for special ops, right? And he was just doing everything good. And those trainers was there saying, yeah, he's doing really good, but you know, the goal is 28 push-ups, he can only do 26. I said, oh, okay. Then I asked the question. You probably could guess what question I asked. Those lack of 2 push-ups, what is he not going to be able to do? They couldn't answer my question. They couldn't answer it, right? So why would you fail someone out over 2 push-ups if you can't even explain the importance of it or the significance of it? So to go back to my one question, right? It's the so what question. So what? What does that mean, right? I don't know if he ever passed or not. You know, I didn't go back and check. But that was disturbing to me that we didn't understand that what those 2 push-ups meant, right? So 90% washout rate. Then if you played high school football, you have 6.5% chance of playing college. Anybody know it's that low? It's low, right? And then, of course, pro is even lower, 1.2, right? So that means that if we have those desires, we better get the training right. We better do the right things to prepare to be able to do field performance, right? That's what I think. All right. So I think there's a performance gap, right? So there's a gap between what we do here in training and what we do over here. I think those folks that are successful at doing it have it already because they're doing other stuff. We're just not measuring it. It's not in our training set. The data's not in our training set. But they have it, so it transfers over. Okay, let me continue. So we came up with what we think elite performers are, some of the attributes, right? We think they're able to seamlessly integrate cognitive and physical abilities to enable effective decision and task execution in uncertain environments. Uncertain environments is a key part of it because if you have an adversary, things are going to change, right? They're going to prevent you from doing something that you want to do, and it's probably change. So you got to be able to respond to that uncertainty associated with that. Then we think they're strategic and adaptive, which enable them to perform above typical human expectations, specifically in real-world situations. Elite performers have the ability to perform efficiently and effectively under extreme pressure, right? So all these folks are under stress, and how you perform under stress, right? So they got to be able to do that. And we think they have advanced levels of open skills, which separate them, elite performers, from average individuals. If you don't know what open skills are, it means dynamic and uncertain. There are things that are planned, and it works exactly the way you want it to work. I'll call that the happy path, right? And there's a non-happy path. If you have an adversary that's trying to prevent you from doing something, you better plan on the non-happy path because they should stop you from going the happy path. If they don't, then they're not a good, anyway, they need to do their job better, right? All right, so through that discussion or through that research, we came up with this thing called TOP. TOP is theory of operational performance. And outside of that definition, I didn't make up that definition. I think it's pretty good. I didn't do it. but we came up with an equation that described what we mean by performance, right? And it involved four key factors. One is accomplishing a train activity, so train that skill we just talked about. And then B is the big one, that's why I have it bolded, by using body mechanics and mental processes. So not one, I need both. I need you to be able to think, I need you to be able to recognize, and then I need you to be able to respond accordingly, effectively and efficiently, right? So that's what that is. And then for executing tactics and strategies and tactics, that means you got to think strategically, and then you got to perform tactically, and then you got to do it within the operational environment, right? Another couple things I want to point out on this chart. So we think the if factor is that middle between physical, cognitive, and psychological. We think all those has a tremendous impact on performance. I'm not saying that's everything that impact performance, but we think these are the major things that impact performance, right? So the if factor is the intersection of that somewhere, right? We also believe that, when I see a lot of the continuum from health, fitness, and performance, it's drawn in a linear fashion. I think it's nonlinear, right? I think just because I think, you could do things to get better in health-wise, within reason, right? And then you could do more things associated with health to get better fitness-wise, right? You might start off walking a mile for health reasons, and you might be able to jog, 5 miles, right? To get in better fitness. But I cannot necessarily do more fitness things to get to performance. Not necessarily. So I cannot lift more or run farther unless those are the things I'm trying to perform in. If I'm running a marathon, running is a great thing. That's a performance. If I'm in a strongman competition, lifting is good. But in those scenarios I just showed you, I don't think doing more of those things will get you to performance. So we think it's nonlinear, right? And happy to have that discussion with anybody who want to do that. And then on the far left, again, I always like to point this out. When we first came up with this was years ago. This had to be 10 years ago. We was talking to Dr. Cedric Bryan, from President and Chief Science Officer ACE, and we introduced this to him. And he said, this is a new field. This is groundbreaking. This is comments to me and a colleague of mine. And I didn't believe him, to be honest with you. But as I go on and have interactions and talk to different people, I'm starting to believe maybe it is, because everybody I encounter don't look at performance this way. So it's a different way of looking at it, right? So anyway, so that's what we call top out 3-year performance. And I'm gonna go over this real quick, but this is a simplified model, and I gotta make sure I'm clear about that. It's very simplified. What we mean, that means that on the far left, it's just the concept, right? You have physical and you have cognitive training that you must do in a separate fashion first. So you gotta build the foundation, get that done first. And then you start to integrate physical and cognitive training. Not do it sequentially, do it simultaneously. Because what we recognize is that when we have someone doing a physical task and a task they have to make decisions, there's a big knockdown factor in their performance. Does that make sense? When I say big, I'm talking about 30% or higher. So if you go back to those drills I showed you earlier about running the 40 or 5-10-5 drill, right, and things like that, if I don't have to think, I could put all my resources to running these sprints. But if someone's chasing you, and you got to elude people, and you got to understand who's blocking for you and what they're doing, that's a different scenario, and they start to slow down, right? So you got to have both, and then you got to do those under stressors, right? So that's what the top one is. You do it under loads, right? I'm not going to go over this, but here are a lot of the factors that we're looking at from a physical cognitive standpoint of view, right? Stability, balance, strength, body control, you get the idea. And so, same thing with the cognitive, which I think is interesting. I'm going to share some with you. You got detection, tracking, memory recall, pattern recognition, situational awareness. Have you ever heard people talk about cognitive flexibility in AI? You ever heard cognitive flexibility, period? Okay. Do you think today's AI have cognitive flexibility? No. Do you think it's important for decision making? Absolutely. Right? So that's why we train that. Do you hear when you watch games, they say, man, that person have good cognitive flexibility? They probably do, but they don't say that overtly, but it's probably part of the it factor, right? So we try to decompose this down and come up with what those mean. Then you have the tenets of top, which I won't get into it, but I will say the first one is no phase left behind. So if you start here, I guess I can't walk away, but if you start at phase one, and you go up, you leave none of those phases behind. That means you always train those areas, so you don't jeopardize one for training or the other. Okay. All right, almost done, I think, right? So any engineers in the room understand system engineer V, right? Everybody understands system engineer V. So we're trying to create this framework around how you engineer human performance, right? So we develop a framework to enable progression-based training based on top, I just showed you, to decrease that performance gap. We want to utilize wearables, questionnaires for evidence-based and feedback. So hopefully you're starting to see the tie-in now to AI and digital engineering I was telling you about, because to me, this is just another product that we're doing. We want to engineer, we want to digitize this product, and we're going to do this using a design framework. If those don't know who this is, a design framework, an engineering framework we use to develop products, right? So we're going to use the wearables to get us that data I just talked to you about. Remember that digital twin, digital thread? We're going to use data to do that. And then we will employ these AI methodologies for data and decision making throughout this process. And so I'll just tell you what this means, this V mean quickly. It means that as you go down, you're decomposing your components of a system. And then as you go up, you integrate and you validate at the end. So we go through this process with human performance to try to get the results that we want to get to, okay? So let's talk about life cycle management for human performance, right? So anybody heard of condition-based maintenance? You must be an engineer. I don't know where you work. I'm going to find out because you raise your hand at everything I say. So that's good, right? So condition-based maintenance is this idea that they came out with. They came in policy in 2008. It was before that they came up with the idea. Right now or before, actually they probably still do it this way, aircraft maintenance was based upon hours, flight hours, schedule-based, right? What does that mean? That means after X amount of time, I have to go and get my aircraft inspected for those critical components. So what happened when I get my aircraft inspected for those components? Is it available? No, it's out of service. You gotta take it out of service. So you take it out of service, and in some cases, they had to take components apart to do an inspection. What's the risk of doing that? The risk of doing that, when you take it apart, you can cause damage. So it's out of service, you cause more damage than by doing so. And what we try to do with condition-based maintenance is have the aircraft tell us whether they need maintenance or not on that particular component. So the Air Force say, yeah, this is a good idea, or DOD said, yeah, this is a good idea. So they came up with a policy called condition-based maintenance, right? And the goal was to increase weapon system availability and reliability while reducing downtime and costs, operational costs. So I'll skip to the last bullet. The most valuable asset we have in the DoD arsenal is the human, and it's not being monitored at all. So we're not doing the same for humans. So one thing that we're working on right now, how do we get that same type of concern or same type of technology embedded into the human life cycle? I shouldn't call it life cycle, it's more like a career cycle, right? With why they're in the military to actually help monitor their health fitness and performance throughout there and do the right interventions at the right time so they can maintain performance. So that's kind of the premise behind this, right? Just a little bit more about what total life cycle system management is. I won't go over all of it, but you can see some of the definition. Material availability. I don't know if you remember, but I had a slide earlier from AFMC talking about material management, right? So this fits nicely in with material availability. Is the measure of percentage of total inventory of the system that is operationally capable. Operationally capable is the key word. Reliability is the measure of the probability of the system will perform without failure. Ownership cost, of course, is balance that sustainment and solution of assuring O&S costs associated with material or readiness. And then downtime is the average total time required to restore assets to its full operational capabilities. So we think those are very similar things we can use for the human, and that's kind of what we're after. So how are we going to do that, right? So with some partners of mine, some in the room, RippleWorks here. Surprised Angie introduced me. I didn't know that, so that's nice surprise. We're working on something called Human Engineer Resilience Optimization, called HERO, right? What we did, we got together a team of folks that can bring different things to the table. The first one is create this innovative training methodology that reliably transfer to operational performance. Hopefully I just made an argument about how some of them do not do that currently today. So we want to use these methodologies that we created jointly with Ed Downs. He's a trainer for a lot of professional athletes. I won't go over the list, but there's many. And so him and I collaborated on coming up with this top methodology, okay? Here's a big one for this forum. How do you develop a digital training aid that coupled with wearable devices and questionnaires to enable quantifiable, evidence-based progression training and interventions to optimize overall performance and well-being? So on this digital training aid that will have AI and other data analytics techniques in it to be able to actually deliver training content, analyze data from individuals, to be able to understand where they at, and then how we can actually optimize or maximize their performance over a lengthy period of time. So the life cycle management piece. Then there's this career life cycle management system that RippleWorks is working on with us, right? So how do we collect, store, and manage this data, right? What people don't realize, we talk about AI, we talk about data, we talk about sensors a lot. That data has to go somewhere. Someone has to manage the data. So if you want to do this, you got to make sure you understand how you're going to do all that. And I think they have a unique solution that afford us the opportunity to deploy this in the near future. So here's the con-up of what it will work like. I'll go over this really, really quick. So to the far left is, you can call that your assessment side piece. So you can have 3D motion capture that create avatar view, look at your biomechanics movement. There are also some cognitive tests you can do. We can deliver those via iPad. We can deliver those to other cognitive devices and training devices. But that gives us and set us a baseline and say where you at when you first start out, right? Then that data, along with surveys, go into that top middle piece where that's where the analysis is done. That's where a lot of the AI or data analytics get done at, to say, here's kind of where you at. And based on where you at, here's your training plan you need to do to improve. So we set these different cycles, if you will, and have you improve in certain elements. Remember all those cognitive and physical factors I talked to you about? Those help you propagate up those different levels to get to optimal performance. So we deliver that, and that's delivered on a mobile device on your phone. So you allow you to see that on your phone while you're working out, and then you execute that plan. Right? So everybody understand that loop, right? It's kind of simple to understand. And then periodically we reevaluate you, and then based on your reevaluation, you either stay where you're at or you move up, right? To optimize your performance, and hopefully the goal is to maintain that throughout your career. So that's kind of the goal, right? Here goes some of the data that we plan on taking in. Like I said, physical data, cognitive data, psychological data, environmental data for that. And then the capability, we want to push out, like I said, baseline, calculating needed for a successful task, job performance. And what we're talking about is what is required. What is your performance, your human performance requirement for the job you're doing? That's what we're saying here, right? That's different than I want you to just max out and be great at everything, because that's not possible. Some of the things you do might not be in the critical path, what I would call, right? So we want to be able to optimize that. Compare, I already talked about this, compare the task, perform and determine the difference, create personalized training, then reassess periodically, right? So that's kind of the goal of this digital training aid. And we wanted to be able to scale, right? So you have this intelligence in this software that allows you to train at multiple different locations. You can have a trainer if you want. The trainer can use the system, or you don't have to have a trainer if you choose that route to go, and this training aid will guide you through that process. All right, so I'm not gonna brief this again, right? I briefed this before. So this is what we plan on putting in it, using wearable devices to collect data. Like I said before, using machine learning algorithms at that point. You got machine reasoning at that point, that is to understand some of the discrepancies that might come from the wearables or other things. Then you have your desired profile. I just told you about setting that profile up. And then it kicks out the training plan that delivers to the individual, right? So that's kind of the goal, using this type of architecture to do it. And again, hopefully make it a little more rigid and less fragile, if you will. So here are some of the dashboards that we're working on of how a commander or someone at a high, or a coach, even that, if you will, at a high level could say, where a person at, the status, and then that way it'll add situation awareness to the organization, because a lot of times they don't have this, so they don't know the status of their organization. That's what we're trying to generate here. And what you see here is just a screenshot of what someone might see if they was doing an exercise that's in the gym. You'll see a video that shows you how to do the exercise, and you record what you've done, and that data goes back in so we can do the analysis. Right? So, in conclusion, right, I think significant advances have been made in the area of artificial intelligence. I'm a fan, been educated in that space, so I'm a believer in that for analyzing large amounts of data and beyond. But even with these significant improvements, methodology still falls short in some cases of meaning making and understanding of that human have, right? Human have this ability to able to look at a scenario. Okay, some don't, right? Some humans don't, but some humans have the capability to be able to do the transfer learning and look at the similarities between what I've seen here and how it mapped to other environments. I think that's what we have that's kind of unique, that machine learning is not quite there yet, right? So especially from novel data sets, and we want to be able to enable robust decision making. The ability for humans to use insights from past experience, like I said, to solve original problems far exceed what we have in AI today, right? So in order to reduce this limitation in AI, we got to realizing that third wave that I talk about of AI, advanced approaches need to be discovered to address these type of problems, right? And I think I'm at questions, and I think that's all I have. I'll let you guys read that one, but that's all I have. Thank you. Yes.
Has the idea of a multi-capable airman or MCA been a motivator or a bane on this approach?
I think it's
good or bad?
I think it's a motivator.
Motivator?
Yeah, I think it's a motivator. Now, I think it's a difficult thing, right? Because if you talk about multi-dimensional airmen, multi-capable airmen, you talking about being good at everything, right? So you can't optimize to one or the other, right? So what we probably do in that scenario is try to max you out on all those parameters that we just showed you, and I think that makes you multi-capable, right? If you try to, let's say, optimize toward one, like a RPA operator, maybe agility, physical agility is not important, So we try to enhance and spend more time on the cognitive piece, right? Special op, you might, probably need to both go up. So I think it's, I really like that idea because I think it supports what we're trying to do.
You talked a little bit about consciousness,
Yeah.
and there are some schools of thought that said AI will never have consciousness.
Yep.
Based on your experience, do you think that AI can be programmed for consciousness? It's subjective, so what would the criteria be? Or is that kind of the saving grace or the human touch point that we'll always need?
Yeah, I should make that clear. I am not promoting that machines going to be conscious at all, right? Not at all. What I am saying, that can we program or engineer some of the characteristics that we have in the consciousness to get some of the behavior. But I'm not promoting that machines are conscious at all. Okay.
So given all the problems you raised with using discrete metrics for evaluation, especially during training and generalizing to active environments, what are your thoughts about using models as evaluators during training time in order to automate that holistic training process and evaluation?
Yeah, so I think that'd be a good approach to do, right? You probably know what I'm going to say, depending on how accurate the model is.
Right.
Right? So if the model's accurate and it represents well, then I think it's a great thing to do. From my experience doing this in the past, the model was not as accurate or represented, in some ways that caused it not to perform as desired. That's the same argument we hear about VR or AR, right? You train in those environments that simulate it, but is that feeling still the same or not? But I think that's what we should go into, absolutely.
Have you explored any of that with the recent foundation models using, some of the chain of thought, some of the reasoning chains that they have? Because you mentioned at one point that the cognitive flexibility wasn't there, but we do see with chain of thought in some of these that the models will change their mind after reasoning as they go through new chains of thought. So that might be something there.
Okay. Happy to look into that. All right. Thank you very much.